Hello, welcome to Algebra 1, lesson 4b.3. Today, we are going to continue learning about math modeling with exponential functions. However, this time, instead of exponential growth, we're going to be getting into exponential decay. So instead of the graph going up, we're going to see the graph going down. So let's get started. So this is class Algebra 1. So mostly ninth graders, some older, some younger, but Algebra 1 and lesson 4b.3, which means we're in unit 4, the second half. It's broken up into 2 parts online. And so this is the life application part or modeling part. And point 3 means that it's going to be page 3 of the module. All right, so here we are. You pay $12,000 for a car, and it's not going to retain its value. It's actually going to drop as soon as you drive off the lot. But so you pay $12,000 for a car. The value of the car then depreciates. That means the value is going down at a rate of 15% per year. Ooh, that circle didn't turn out right. You paid this much and it goes down that much per year. How much will your car be worth after 3 years? So the question is after 3 years. So let's start this out the way we started out our growth ones, where we're going to create a chart here. So year 0, that means its initial value. So it was $12,000, right? And then year 1, let me grab my calculator. All right, so year 1, it has gone down by 15%, right? So we're going to take our 12K and we're going to multiply it by 15%. That's 0.15. And we'll figure out how much it's going to go down. So 12000 times 0.15, my answer is going to be 1,800. Okay, but that's not the new value of the car. That's how much it's going down. So we actually have to subtract it from the 12K. So I'm going to do 12K minus 1.8K, or 12000 minus 1800. And I get 10,200. So this is 10,200 that the car is now worth. And we're going to repeat that same process. But if you notice, just like when we do discounts on if a TV is on sale and it's discounted by, say, 15%, instead of doing these two things where we have to multiply by the discount and then subtract it from the number, we can actually multiply by what's going to be remaining. So if we had 100% and we're taking off 15%, we're going to be paying 85% of the cost. So it's the same here with the value of the car. The car is not, we don't have to figure out how much to reduce it by if we just figure out how much is left. So we can just multiply this number by 85% or 0.85, and that's going to give us our new number. So I'm going to take 10,200 and I'm going to multiply it by 0.85 to get my next number. All right, so I got $8,670, and I'm going to repeat that 0.8. I'm going to multiply that by 0.85, and I get $7,369.50, right? So you can see that I have all of these answers here. But before look at that, I wanted to show you some of the we actually have, just like in the exponential growth, we actually have a formula for exponential decay as well. So I don't have to actually figure all those out in the way that I was doing it before. I can create a mathematical sentence and then just plug in the number of years in order to figure it out. So what is that formula? Well, let's look at it here. Here's our formula. F of t is a times 1 minus r to the power of t. Remember when we had growth, it was 1 plus r. This time it's 1 minus r. So you can see decay is going to have this minus here instead of growth had a plus. And that's the main difference. So when we look at this, a is still the initial value. F of t is still going to be the output or the amount that you're going to get at the end. What is the answer over a period of time? R is still the rate and t is still the time interval. So looking back at our problem we have here, how much will the car be worth in 3 years? Let's actually, I did not remind you. Please pause the video and take time to write down this formula and all the information here, okay? All right, so since you have that written down, you should know f of t is a times 1 minus r to the power of t, okay? Exponential decay formula. That's our general exponential decay. So let's write this as a formula. Well, what is our A going to be? Our initial value. Our initial value is 12,000. What's our rate? Our rate is going to be 0.15 because we need it as a decimal, not a percent, right? And T is going to be years because we see that it says that it is 15% per year. T is years. Okay, so when we create a formula with this information, we get f of t is 12,000 times 0.85 to the power of t, because we did 1 minus r. 1 minus r, that's 0.15. 1 minus 0.15 is 0.85. So this has already been reduced for us here with this 0.85. Okay. And then the graph that we have is here. It shows those points that we looked at, 0, 1, 2, and 3 years. And then we've got some questions here for you. You get to answer these questions and see if you can find the answers, which I have confidence you can. All right, so you should have paused and looked at the answers, and now we're back. What is the y-intercept of the graph? Okay, well, the y-intercept of the graph is right here, okay, 0. And then it looks like, so we go between 5,000 and 10,000, 1, 2, 3, 4, 5. So each of these lighter lines is 1,000. So this is going to be 12,000, right? And so the y-intercept of the graph is 0, 12,000, or 12K is how I like to abbreviate it. And so what does this represent? Well, this represents the initial or starting value, right? Predict the value of the car after 10 years. Well, here's 10. Remember, this is our years because this is our input or independent variable. This is our output or our dependent variable. So after 10 years, the car is going to be right about there. We know that's 1,000, 2,000, in between $2,000 and $3,000. And it looks like it's just a little bit less than halfway. So I'm going to say it's approximately, these squiggly equal lines mean approximately. It's going to be approximately, let's say $2,400. In how many years will the car's value be about $5,000? So we're going to, instead of looking at the input, we're going to look at the output here, the value. And let's follow it over. It is right about there. So it's shortly after 5 years. So maybe 5.5, maybe a little less. So we'll say approximately 5.5 years. Okay. So there's the answers. I'm sure you got them all right. I'm excited about that. And so we're going to go on and look at another problem here. A construction company purchased a new bulldozer for $25,000 and it's decreasing. Let me highlight this information, 25,000 at a rate of 3% per year. So we already know that A is 25,000 or 25K. R is going to be 0.03 because remember the decimal moves 2 places over, and T is going to be in years. So we need to pay attention to that. Make sure our question is also in years. Write an exponential decay function to model the situation. How much will the equipment be worth after 5 years? Okay, well, we can write a problem here. I remember that my formula is f of t is a times 1 minus r to the power of t. So let's plug this in. I know that a is 25,000, so f of t is 25,000 times 1 minus r is 0.03 to the power of t. Now, how much will it be worth after 5 years? All I'm going to do, because this is years and t is in years, is I'm going to plug 5 into where the t is and enter it into my computer and hit enter. So what am I going to put in my calculator? I'm going to put 25000, open parentheses, 1 minus 0.03, close parentheses, caret 5. Remember that caret is allowing us to have an exponent that's something different than 2 squared, which should be a button on your calculator. So let me plug this in. All right, it looks like that will equal $10,304. And it says 80831. So since this is dollars, this is a money, we need to round to the penny spot. And the 8 is going to tell us to round up. Okay. So I'm going to erase all that and say it's 81 cents, $10,304.81. Now, just like with exponential growth, sometimes instead of being given the X value, you're giving the Y value or the output value. So, and asked how many years will it take? So we need to use a calculator to figure this out just like before. But first, let's look at our information and remember what our, let's see if we can remember what our equation was. Now, if you're asked what the equation is on a test or an exam, you cannot leave it with 1 minus 0.03. You would need to do that math and do something like f of t is 12,000, 0.97 to the power of t. Okay, so this would be the correct answer if you were asked for the formula on homework or a test instead of this one, because you are supposed to simplify your formulas. Okay. All right, so moving on, let us go out of here and look at the calculator again. All right, so here we have our calculator. And oops, I forgot my pen doesn't work on the calculator. Let's go exit out of here. Let's get back to y equals. There we go. Y equals. And I'm going to clear out the formula that we had in there before, and I'm going to put in a new formula. You can either use the simplified version, which is what I'm putting in the parentheses here, or you can use the original formula, which is also good. And remember, instead of t, we're going to be using x because our calculator is going to use y's and x's, the standard equation letters. All right. Now, we don't need to see the graph, but we can look at it just for fun, see what if we can see it in this window. These when those things were moving right there, it says it was still working. But our window set is currently such zoomed in that we can't see it. So let's go ahead to the table, second table. And what was our question? Our question, remember, was to see how many years will it take to be worth approximately $19,000? So we need to go to 19,000. It started at 12 and it looks like it's increasing. So I must have done something wrong. Let's look at this. 12,000, 0.97 to the power of X. Oh, no, it's decreasing. I don't know why I thought that was increasing. 12,000, 11,000. So we're not looking for 19,000. We're looking for 1,900. That must be what it said. I must have typed it in wrong. Instead of 1,900, it should be 1,900 because 25,000 decreasing at a rate of 3% per year. 25,000. What did I do? Oh, I put 12,000 in instead of 25. There we go. All right. So when something doesn't make sense, you need to figure out what's going on. Where did we mess up? And that was a good example of it. I wrote the problem wrong because I wasn't paying attention to the details. I wasn't looking at what was on the actual question. The actual question said the equipment was bought for 25,000, but for whatever reason, I wrote 12,000 down, and that's what I plugged into my calculator. So I wasn't able to find my 19,000. So it wasn't making sense. If it's not making sense, go figure it out. If you need to, just erase everything and start over from the beginning so that you can find out where the error is, because we all make mistakes. All right, so 25,000, let's look back at year 0. I'm going all the way up to year 0 to make sure it's starting at 25,000, and it is right there. So I wanna see at what year will it get to be 19,000? Well, year 9 is 19,006, okay? So remember, this is at the end of the year. So the end of year 0, it's still 25,000. The end of year 1, it got down to 24. And so it's the end of year 9 that is $19,006. So we can't say 9 years because it's still worth more than 19,000. So it's in the 10th year that it will be worth $19,000, the beginning of the 10th year specifically, because it was so close to that end of that 9th year making that point. So let's look back here at our problem. How are we going to answer this? All right, so after how many years will the equipment be worth approximately? Since it says approximately, we can just go ahead and say 9 years, because at 9 years, remember, it was $19,006. So we can say after 9 years, the equipment will be worth approximately $19,000. There you go. A word problem gets a word answer. All right, so just like before with exponential growth, we had a special kind of formula for compound interest. Well, with exponential decay, we have a special kind of formula called half-life. Now, you'll find out later in your science classes what exactly half-life is, but it's basically the carbon that's left, or the amount of material that's left after so many years. So how long does it take something to divide in half, like for it to decay down to halfway? So if iodine 131, it takes it 18 days. So this just means this is an isotope. If you're into chemistry, this is an isotope of iodine 131. It takes 18 days to disintegrate halfway. Okay, so after 18 days, it's half as much as it was before. And then after another 18 days, it's half as much as that. So 1/4 of when it started. And after that, another 18 days, it's half as much as that. So our T here is going to have to be a little bit different. It's very similar to what our compound interest is going to be. But when you talk about half-life, your rate is always going to be the same. Your rate is always going to be 1/2, no matter what. No matter what, this is your rate, 1/2. So you have the function of time is A, this is your initial value. Okay, so the initial value in this would be 35 grams. So A is going to equal 35, right? And so there's no R here because we already know when we deal with half-life, R is always 1/2. So we don't have to write R in, but if you were looking at a formula and you didn't have 1/2, that's where it would go. T is going to be the time. So in this case, it's going to be that 32 days because the half-life is 18 days, right? So we need our T to equal days because the half-life is in days, all right? So we have, let's make a formula here. F of T is 35 times 1/2 times T over the half-life of 18. So this is our formula right here. And we need to fill it in with what goes in T right here is 32 because that's 32 days. So sorry about that phone call. F of T is 35 times 1/2 to the power of, this is, I did not write that fraction very well, to the power of, and it needs to be in parentheses again. Okay, so you'll have in your calculator 35, open parentheses, 1 divided by 2, close parentheses, caret, and you're going to need to open your parentheses again. I don't know why I put T there. Let's see. This should be 32 here, 32. So open parentheses 32 divided by 18 and you hit enter. So we know that after 32 days, iodine 131 will be 10 point, it doesn't tell us what to round to, so we'll say be approximately 10.2 grams. And so that's how you do half-life. So we have another equation here. Let's try to remember our formula. It was F of T is A times 1/2 to the power of T over half-life. Okay. That is the exponent. Remember, it's going to go up above. So this time we're looking at carbon 14. It has a half-life of 5,730 years. So let's go ahead and write this. The half-life is that. We know that this is going to be our A, 100 grams. And so let's go ahead and write this in. 100 times 1/2 to the power of T over 5,730. Now, how much carbon will remain in a 100-gram sample after 11,460 years? So let's make sure that our measurements match our units of measure. We have years and years, so we can just plug this into where the T is. So in my calculator, I'm going to put 100 parentheses 1 divided by 2 close parentheses, caret, open parentheses, and I'm going to plug this in where the T was. 11,460 divided by 5,730 close parentheses. It's imperative that you use these parentheses or else you will not get the correct answer. All right, and so the answer is 25. We will have 25 grams remaining after 11,460 years. So this has to do with how they do carbon dating. and how they can tell how old something is by telling how much carbon is left in an item. So this is definitely used later on in real life. All right, so I've got some practice for you. Pause the video and come back when you're done. Mr. Dale buys a car for $18,500. The value depreciates at 19% per year. So T is years, A is that amount, and our rate is going to be 0.09. Write an exponential decay function for this situation. All right, so f of t is 18,500 parentheses 1 minus 0.09 close parentheses to the power of t. Now, since it asked us, our question was to write the equation. We cannot leave it like that. We have to subtract 1 minus 0.09. And so our final answer is f of t is 18,500 times 0.91 to the power of t. And that's your final answer. All right, so the next question is, how much will Mr. Dale's car be worth after 3 years? So you're going to put this in. How much will his car be worth after 3 years? Plug it into your calculator. I don't need to write that out for you. You should know how to do that already. All right, all we did was plug in the 3 where the t was, and our answer is 13941.06. So Mr. Dale's car will be worth this much money after 3 years. Approximate when the car will be worth about $10,000. All right, so in this case, we will need to use that calculator that I have in the background. So I'm going to have to clear this screen. Should have done that first. F of t is 18,500 times 0.91 to the power of t. And we're looking for when f of t is $10,000. All right, so let's jump over to the calculator here. Go back to our y equals. We're going to clear it out and plug in the 18,500, 0.91 to the power of, in this case, we have to use x, remember? And then we're going to go to the table and we're going to go over here and we're looking for 10,000. This does not look like I did it right. 18,500. Oh, I forgot my point there. That's what it was. 0.91 close parentheses caret x. All right, going to the table this time, let's make sure this looks right. Our 0 year, we have 18,500, and we're looking for when it gets to be 10,000. So it looks like at the end of the second year, it's $12,686. The end of the third year, it's $7,916. So it's sometime in that third year that it gets to be that value. So let's go back here and write our answer. Oops. Our answer for this last question is, in the third year, the car will be worth approximately $10,000. All right, so last set of questions here for you have to do with half-life. Go ahead and pause the video and work them out. Welcome back. The half-life of a particular element is 10 days. We don't need to know what the element is. That's unimportant to our question, but we do need to know that it's 10 days. If you begin with 40 grams. We know that that's going to be our A. This is our half-life. And T is going to be days, right? 40 grams of the element, write an exponential decay function that models the decay of the element. Let T1 represent 1 half-life or 10 days. Okay, so we know it starts off, our function for half-life, our formula for half-life is A 1/2, and then we have T divided by the half-life. So let's write this formula. A was 40, 1/2, and you could use 0.5 if you wanted to. And then T over, what's our half-life? It's 10 days. So we're going to put 10 there. So what are we going to put into our calculator? We're going to do 40, 1/2, caret, and then it says the half-life of a particular element. Oh, we're just asked to write the formula. So that's our formula. How much of the element is left after about 40 days? This is where we're going to put it into our calculator. 1/2 caret 40, parentheses, 40 divided by 10, because this is days and we know T needs to be in days. So we're going to plug that into our calculator. All right, so we got 2.5. So that is in grams. Oops, I wrote 4, but it's 5. 2.5 grams is how much of this element will be left after 40 days. All right, I'll see you on the next lesson.